to the internet. Is that mean that one?
Exactly.
Those storage, Windows servers, and any application server like JBoss, Tomcat, and we have. So we can install there and we can publish into internet. Is that the type of only services it's providing?
Exactly, right? So if you want to create your application, right, you have a Tomcat server, right, you have a Cisco server that you want to run. So rather than running it on the physical hardware, you create a virtual machines, right, in which you can install your application and you can run your workload as you are running in your offices, in your on-premise data center.
Yeah, but the end user, as we are getting through the internet, so we are thinking just like it's software or it's given as an internet interface. But at the deep bottom, we should have somewhere some hardware, any server hardware, like it's provided by either Verizon, Cisco, or some other server provider. They should have those configuration already ready. So then only we can access through the internet, right?
Exactly.
If I'm not wrong.
Exactly. So hardware is managed by the cloud provider. In that case, it is AWS, Amazon.
Okay.
Right? So cloud is basically the virtualization technology, right? So I can deploy cloud in my on-premise data center as well. We term it as a private cloud, where I can use that virtualization technology, right, by using the virtualization tool in my on-premise data center. But what is the difference here? I deploy a cloud in my on-premise data center, and along with that virtualization service that I have, I am managing the physical infrastructure as well, the servers, the networking component, all those things I manage. So that's my private cloud. And if I want scalability, I don't want to manage this physical infrastructure on-premise, but I want the services of the cloud, compute, networking. In that case, I can go to the cloud providers, the giant of public cloud providers. We have AWS, we have Azure, we have GCP. They also provide us cloud-based services, but here we get the services, but the infrastructure management is done by these giants.
Okay.
Amazon, Azure, or GCP. So they are managing the underlying infrastructure for us.
Yeah. Okay.
Okay. And in case if you require that you don't want public cloud, you don't want everything on the cloud, in the public cloud, you don't want everything to be managed by you, you can also go with a hybrid solution. So some part of application is running on-premise, some part of application is in the cloud. So you see that what kind of deployment model you require, whether you want to use public cloud, you don't want to manage the infrastructure, or you want to manage the complete infrastructure, create your private cloud, or if you want to extend your private infrastructure without making any investment, you would use a hybrid model, which is public cloud, services of public cloud, and your private cloud that you have. So you decide what is the model that is suitable for you and run your infrastructure over a cloud. Okay? Is the idea clear?
Yeah, one more question here. So this cloud provider, these giants are there, right? AWS, Azure, GCP. Previously we used I have used already in Cisco server, we used a hypervisor, and based on that we are giving services to different deployment teams, and those teams, they can deploy their application into those servers with help of the hypervisor. They will feel like we have separate servers, but it's underlying that there is only one server. So it is the same thing they are doing. Our cloud is some different software which is now we are using.
It's exactly same as I said. Cloud also use those virtualization tool, as I said, hypervisor. What hypervisor does, underlying physical server you have. So we have a physical server, and to make sure we utilize the server up to the full capacity, we use hypervisor as a software layer, right? And then each team can create its own VM. Same is in the cloud. Same is there in the cloud. They have this virtualization that manage the physical servers, And on this physical server, you can run your VMs for your working.
Oh, okay.
Okay?
Yeah.
Fine. And here you can see on the screen, we have a dashboard of a cloud. So whenever you log into the AWS, you'll be able to see that page. So if I go to the landing page of AWS, you can see the console from where you can access the AWS services. And if you want to run your workload as well, you can run your workload on cloud, right? So it's taking a little longer. Let me see.
Hi Kamlesh, can you please rerun again because my screen got stuck.
Okay, I'll just share it once more. Just give me 1 second. Okay. Nilesh?
Yes, now it's visible to me.
Sure, no problem.
How you go into this dashboard?
Yeah, so to get into this particular dashboard, you can sign into the AWS account, right? So either you can create your own account, or if your organization provides you access, you can sign in as a IAM user. So we'll talk about that. But if you need to log in, right, we can simply go to the page console.amazon.aws.com. And once you get on that particular page, you get the option to sign in as an IAM user who perform daily tasks, right? For example, you deploy the application, you inspect the services, right? So you perform the daily tasks. So you can sign in as an IAM user, or if you are owner of an AWS account who created that account, you can sign in as a root user. So we'll talk about that. So that's a console from where we can log in as an owner of our account or as a user of our account, which is getting the job to perform the daily tasks. Okay. So we'll talk about that in some time. We'll see that security module, right? There we'll see that how we access the console as well. I just wanted to show you how the console looks like when you sign in there. Okay.
I have another one question with me.
Sure, Nilesh.
As earlier slides, what will be the as perspective of certification, how the question will be phrased related with this? Any inputs you can give? If any questions
related to
will cover this slide with what kind of cloud computing getting used like that.
So you're talking about questions in the exam?
Yeah. Yes.
So in the CPE Cloud Practitioner Essential exam, right, you don't have this question, what is cloud computing and all. You generally get the questions with respect to the services, right? For example, you want to configure a Tomcat server, right? And you need to make sure that you need to save a cost on Tomcat server. So where you can run your Tomcat server, right? Which compressor? So you have questions. This is just the first module to bring all members on the same page what is cloud and what benefit a cloud brings there. So module 2 onwards, you'll see the services in which we get the question, and if you need, I can bring some questions as well for discussion there. Right, so I think my colleague dropped the sample question in the chat. You can see which of the following AWS service is used to store and retrieve any amount of data at any time from anywhere on the web. Right, so you have questions based on the services of AWS there.
Okay, got it.
Okay. Right, so you have seen how the model, how the landing page of AWS looks like. I have just showed you that. We'll talk about more how you can get access as well. Let's talk about the benefit of a cloud computing, what benefit you get with the cloud computing. So first benefit that you get, you don't need to make any capital expenditure, right? You simply start using the services, and the amount of services that you use, you pay for the same, right? So we don't need to make any upfront expenses to buy the infrastructure. The infrastructure is there with the cloud provider. You just demand which services you require and how long you want to use that services. Pay for that. So we can have variable expenses rather than upfront expenses for the resources that we use. Apart from that, there is cost optimization as well, right? So how the cost optimization is there? Now I don't need a team to run the data center that I was running, right? Because now this entire part is managed by the cloud provider, right? My job is to run the services, develop the applications over the infrastructure that is provided by the cloud provider. I don't need to worry about the physical server when its hard disk is going to fail, or when I might have an issue with the power. Now everything is managed by AWS. So we can focus more time on building the application. We can optimize the cost there by quickly releasing the application, because we don't need to put heavy lifting that we were doing in running the data centers, right? We don't have to put that particular time. So we can optimize the cost as well. Apart from that, now we don't need to guess the capacity. Previously, if I was running a data center, I need to predict, I need to project what will be the requirement of the infrastructure for my applications to run in future. Because to set up the infrastructure, it takes a bit of few weeks to months, right? And we can't wait for that time for our application to grow. But with the cloud, you don't need to guess capacity. Today, you require one virtual machine to run your workload, and tomorrow in the night you get familiar and look at today, tomorrow you require 20 such machines to run your workload. You can get that within few minutes. You can get those kind of machines infrastructure for you, so you can scale as you need. No need to guess the capacity, the requirements that you have for your infrastructure initially, right? Because cloud is scalable and you can get the elasticity in the cloud for the resources that you want to utilize, right? And with the cloud, especially with the public providers that we have, the public clouds, we have AWS, right? Such as Azure or GCP, right? Now these cloud providers, right, having a huge number of customers, right? Already huge number of customers running their workload in the cloud, and AWS created the infrastructure at a huge level, right? It has its reach globally, and due to which they were able to set up their data centers at a lower cost, right? And they provide the same benefit to the customers. And due to they have a large customer base, they can provide the same services to you at a comparatively low cost compared to if you create such data center yourself, right? They already have a huge customer base, and due to which they are able to offer the services at a lower cost, right? So benefit from customers' aggregated usage, right? That's been given to the customers. Going out further, you can increase your speed of development. As I mentioned, we don't need to wait for week for resources to get available. Within few hours, you can get your resources in the cloud computing, right? So that's a benefit that you get. You can go global in minutes. Now, if your customer base is in US, you want to deploy your application for US customers, you don't need to worry about anything. You can just go to the cloud, select the region of a US, and deploy your application in the US for your customer base. So here you can see that the reachability of a customers, right, cloud across the globe. So I can go to US, I can go to US East, US West. In the Asia Pacific region, AP Northeast 1, Northeast 2, Singapore, Seoul, Mumbai, Tokyo, you can see most of the regions are there. We have the reachability of a cloud. So if I go to the global infrastructure of AWS, we can see the reach of AWS across the globe. So over the map, you can see AWS has already covered the globe with the services that they provide in various different regions. And still it is expanding. You can see we already have a blue dots where the regions are already established, and we also have a red dots, right, where the region will be coming soon, right? In Germany it is coming up, in Chile it is coming up, in Saudi Arabia it is coming up, with the new regions there. So if you want to reach globally to your customers, you can run your workload across the globe and you can reach there in minutes. So if you're ready with the plan, you can reach your customers globally in minutes, right? So all these benefits the cloud provides you. And apart from that, when we go with the cloud practitioner, we'll see the core categories, right? Compute, database, network, security, storage, and also management and governance, how we can apply the control or the workload that we are running. So we're exploring some of the services from these categories to understand the AWS services, how it runs, and also that's the first stepping stone to get ourselves familiarized to AWS. Okay, so I hope the idea is clear, the three different deployment models that we get: private cloud, public cloud, or a hybrid that you have, and the benefit it brings to you. You can go global in minutes. You don't need to guess capacity. Okay, why global infra is required? Is it for the latency / performance? Yes, of course, because if I run the server in Indian region for the customers in US, right, definitely there will be a latency. So it will be great to run your application closer to your end users who are actually going to use your services, right? So to improve the performance of our application and to reduce the latency, we have the availability of a cloud across the globe. Okay. So let's quickly have a knowledge check. So what is cloud computing? So what do you feel? We have talked about the cloud computing. So which option you feel is correct as per the content there that we have discussed? Right. So I can see the correct answer appearing in the chat is the on-demand delivery of IT services over the internet based on your need. Right. So that's option C. Great. Let's go to the next question. What is another name for on-premise deployment? So we say that I deploy the services on-premise, right? I use the cloud in my on-premise environment. So what is another name for the same? Guessing? So I can see answer again appearing C. So it's very, very difficult to differentiate there. So that's right. I can see C started appearing. So it's private cloud deployment. So you can run the cloud in your on-premise data center as well. We say it's a private cloud. Or if you go with the public cloud providers, right, where infrastructure is managed by the huge joints like Amazon, right, that's AWS, right? And the next question, how does the scale of cloud computing, right? How does the scale of cloud computing, the global cloud providers that we have, that help you to save the cost, right? How you are able to get the services at a lower cost with the cloud providers? Awesome. I can see the correct answer appearing in the chat. Because they have a global, huge customer base available across the globe, and they are able to deploy the resources at a lower cost, and due to which they are able to offer the services at a lower cost, right? So the aggregated cloud usage from the large number of customers result in lower pay-as-you-go prices. Right? That result in lower pay-as-you-go prices. And that completes the module for us, right? Where we just talk about the cloud, what benefit it brings to us. So I hope now all of us are on the same page, what is cloud. And in case if you have any query, do let me know. If all is good, we can go to our next module, that's compute in the cloud. So all good, team? Awesome. Great. So let's begin with our next module. I can see hand high. Okay. Fine. So let's begin with our next module, which is compute in the cloud. And team, I think I forgot to mention about the breaks, right? We have the session for 4 hours, right, from 7 p.m. to 11 p.m. Right. So what we'll do, we'll have the session for around 75 minutes, right? 1 hour, 15 minutes we'll have a session, and then we'll go for a short break of 10 minutes, right? So every 1 hour, 15 minutes or 1 hour, 20 minutes, we'll have a short break of 10 minutes, right? where we can move and we can grab a cup of tea or a coffee, right? So that's how we'll be having 2 breaks in between the session, right? One break is around 8:50, and the next break that we'll have around 9:45 somewhere. Okay, so 8:50 and 9:45, we will have 2 breaks of 10 minutes there in the session, right? So I forgot about breaks to mention, right? So that was the break time that we have in between. Okay, let's begin with our module number 2, which is compute in the cloud, right? And what we are covering up in this particular module, we are talking about the compute services that we get in the cloud. So the first service that we have is EC2. So we'll talk about EC2. What is EC2? EC2 stands for Elastic Compute Cloud, that allows you to run your virtual machines in the cloud. Cloud provides you different kind of machines, as we know that when we buy a machine, right? For example, if I want to buy a laptop, I know that I'll be doing a development task in that, so I'll make sure I require at least 8 GB RAM and maybe i5, i7 processor I require there for my daily job, because I run to the development as well. And if I need to buy the same for my son who need to play the games, all right, and nowadays we know that the games are a little bit heavy, so I need to make sure that if I buy a laptop for my son, then I will make sure my laptop has also a GPU in it, so that the game can run smoothly, right? So we buy the machines for different work. They have different requirements, right, of the resources there. I might require GPU, I might require i5, i7, I may require more RAM there, right? So we'll talk about different instance types as well. As per the workload, I may require different kind of machines. Apart from that, billing options that you have for the virtual machines if you run in the cloud, how you can save the cost, right? We'll also talk about scaling. That's a feature that cloud provide to us. Scale your resources based on the need, right? We'll also talk about load balancing, how we can balance the load across the machines, right? And we talk about the services. Nowadays we use microservices, right? And we want to send messages across the microservices. We want to send the notifications. We want to decouple the microservices. We'll talk about messaging services, SNS and HQS, right? And we'll see other compute options in the cloud that is available that can make use of. So let's begin. Let's talk about the topics, right? Whatever we have in the objectives, right? That's what we have in the topic. Let's begin. And let's talk about the EC2 as a service, right? So EC2 helps you out to create a virtual machine in the cloud. And if I create a server in the cloud, I may have a client. So we have the same analogy, customer and barista for the client and the server, right? So if you want to create a server in the cloud, EC2 is one that can help you out. So EC2 is a service that can help you out to create virtual machines in cloud, and you can access these machines securely, and even you can resize your virtual machines. Today you are running a virtual machines with 2 CPU and 4 GB RAM. Tomorrow you require maybe 16 CPUs and maybe 64 GB RAM. No problem. You can resize your servers, and you can get these servers. You can boot these servers in minute, and the amount of time you use that service, you pay the cost for this, right? So let's quickly see that how we can run the virtual machine in the cloud. It's very, very easy. Launch and configure your instance. So launch your instance, connect to your instance, configure it, and once you do that, you can use the server to serve your client. Okay, so what I can quickly do here, I can get into a console, right? So I'll get into a console, and in the cloud of AWS, if you want to go to a service, you want to jump to a service, right? That's my landing page that I have, the console of AWS. And if I need to go to any service, of course, I can go into the categories here, right? And I can look out the service compute, and I can select EC2. That's one way. Or you don't want to get into that detailing, you just want to get the services, just type the name of service as I said EC2, and here you can see it is filtered out for me the service name. So that's my friend, a search box that can help me out to get the service quickly. So I'll quickly get into EC2, right? And what I can do there, I can simply say launch an instance, right? So I'll say launch an instance. Here you can see the instance is getting launched. I can give a name. I'll say that this is my server. You select what kind of OS you require, what kind of machine you require. We'll talk about that. And to get into a machine, we use a key pair to log in, right? Rather than username and password, right? That we have a regular way. We make a use of key pairs, which is more secure. And let's keep everything default. And let's launch a machine, right? So I'll select everything as a default and I'll launch my machine. And you can see that I launched my machine at 7:41, and in a minute we'll see that the machine is in the running state, right? You can see machine is in running state and the check is going on, and within a minute you will see the machine is available to me, right? Within a minute a machine is available to me. I can connect to this machine. Okay, I can connect to this machine. You can see I'm connecting a machine here, and once I connect this machine, I can install an application on it, right? So let's quickly see. I'll just install simply Apache server here, and I'll see that are we able to run the HTML page on this Apache server. Okay, so what I will quickly do, I'll run a command simply here, sudo yum install Apache server. Okay, I'll just do that. And apart from that, right, it installed that Apache server for me. And what I can quickly do here, I can start this Apache server. So I can do sudo systemctl. I'll just check the status. So it's in the stop state. I'll just start this Apache server. And I'll just update my page. Right? I'll just update my landing page. Right? So I just configured my server. I'll copy the public IP of my server and I'll drop this in the chat. Then you can check it out. Is it running the machine? And are we able to see the landing page? On the IP, I just shared the link in the chat. And let me just open that particular page. You can see in 2 minutes, we are able to see the landing page here. Right? So you can see the landing page on the virtual machine that I configured my Apache server, and we can run any application, right? So launch your instance, configure your instance, and provision the same. The website is logged. Is it? See, the website is not accessible.
Yeah, it's blocked.
Is it same for all the members team?
So basically it's blocked because of the TechM policy, I believe.
Yeah, because of the TechM policy, it's basically blocked. Yeah.
Or you can open this in your mobile phone as well. It's hardly 4 digits we have. So you can open that in your browser of your mobile phone. You will be able to see that, right? And just give me 1 second. It's raining heavily in Mumbai. So just give me 1 second to close the windows due to that noise. I think maybe there is a glitch. Just give me a second. Okay, I'm back and I can see update from a Bharat. Bharat is able to access, and you can access on the mobile as well. I can see the update, right? So you can see in few minutes you can have your virtual server running in the cloud, and you can configure your application in that virtual machine, right? So that's a beauty that we have with the cloud. We can get the resources deployed in few minutes, right? So you can run the resources that you require in the cloud in few minutes. That's the beauty that we have. Now, I said I can run a virtual machine and I can get the different kind of machines as well, right? So let's understand different EC2 instance types, all right? So again, we have an analogy of a coffee shop. Now I have an employee. Every employee can do any work. An employee can work as a cashier. An employee can make a coffee. An employee can fill up the inventory. So every employee can do this particular task. There is no problem. But when we are at work, right, we want to make sure that every employee does the task for which it is more suitable or more efficient. So rather than making an employee to work all the job, make an employee to do one task with efficiency, right? So here you can see I just make sure that every employee just perform one job. And same as in the IT, I might want to run an application, but application may have different needs. Sometimes I required a balanced compute and memory. I can go with the instance of type general purpose that gives the ratio of CPU is to memory in 1:4. So that is the ratio of CPU is to memory with general purpose instances, right? So if you want a balanced amount of compute and networking, I can quickly go into the instance types in AWS. And when you go to the landing page of instance types, first option we have general purpose. And if you see different kind of machines we have here in the category of general purpose, and here you can see the ratio 1:4, 2:8, 4:16. That's the ratio of the compute and the memory that we have. If you need more compute power, you can go with compute optimized instances, which provide the ratio of compute is to CPU, CPU is to memory is 1:2. So one CPU against 2 GB memory, right? If you need more computation power, go with compute kind of instances. If I go back, you have different instances here. You can see 1:2, 2:4. Similarly, you need more memory, go with memory optimized instances. That provides you ratio of 1:8, one CPU against 8 GB memory. So you select what kind of compute power you require. You require a support of GPU. You want to run some machine learning tasks. You require the support of a GPU. Then you can go with accelerated computing. That also provides you the GPU support, right? And you want a higher performance on the secondary storage, right? You want to store the data in the secondary storage with higher performance. You want more IOPS for the secondary storage. Go with storage optimized instances, right? So you have a different categories of instances available to you, and you select based on your workload requirement. And of course, sometimes we don't know what is the kind of compute I require. Maybe I cannot guess which machine will be suitable. I don't want to get into documentation, search all these things, right? I want AWS to tell me that what kind of machine can help me out. So when you launch your instance, all right, I'll quickly click here. Here you can see in the instance type, you have an option to get an advice. Okay, you have an option to get an advice. So if I say that get advice, right? Workload type, what you want to run? You want to run data warehouse, you want to run NoSQL, you want to run ETL workload, you want to run Hadoop file system, you select what you require. So maybe I want to run web server. What is your use case? Are you doing web hosting, gaming, CDN network, what you require? You select it, and based on that, it gives you the suggestion. You want high performance, you want low cost, because machine might have different costs as well. So I'll say I want low cost content delivery network to be created, and any CPU requirement. Are you preferring Intel, AMD, Graviton, or Mac processors of Apple? Okay, do you have any requirements? If not, just say get instance type and it will give you that particular option. Right? Which machines can help you out with that particular workload. So you also
Hello, am I audible?
okay. Sorry team, I think I had a network glitch. Am I audible now?
Yes,
Yes,
now you are.
Yes.
Yes.
Right. So I think maybe due to the weather, there was a network glitch. Okay. Thank you. Right. Now this advice is available free of cost to us. We don't need to pay anything. It's simply a tool that we can use to identify which machine can help us out. Yes, Durga Prasad. Any query? Pause. No problem there. Your hand was high. Great. Fine. So you have different kind of machines you can use there, right? Based on your workload requirement, you can select that different kind of machines, right? So just to test, right, that you might have a different requirement, which machine can help us out. Shubham, any query? I can see your hand is high.
Yes, actually I asked what's the difference between 1:2 and 1:4 in performance, and I got a response that it is memory to CPU ratio. But can you explain in more layman language what that exactly means or where we can utilize that? Any examples on that?
Okay. Any examples on that? Okay, fine. So when we talk about the fundamental power of a machine, we talk about the CPU. So if I go to buy a laptop, right, as I always boast that I bought the i7 processor, right, which has 8 cores, which has 16 GB RAM or 32 GB RAM. So the more RAM you have, right, the more RAM you have, right, your application can run quickly because RAM is a primary memory that we have, and in this primary memory we can store the application state. So I will be able to access the application at a faster pace if I have more RAM, right? So depending on, generally when we buy the laptop, we say that we require more RAM so that we can run the applications, multiple applications smoothly, right? And in the cloud we have a different workload. Sometimes we require more compute power than the RAM. For example, right? For example, let's say you are doing a job of creating a animation movie, right? You are doing a job of creating an animation movie, right? So you run the Adobe software, you create your frames. So at that point of time, you require more computation power because you need to edit the frames, you want to work with the pixels, right? And images are heavy there. So you require more computation power to edit or to create your frames in that. So I require more computation power, right? Or maybe you want to run basically some of the jobs in parallel. You are running Microsoft together, you are running Apache server on your machine, you are running containers on your machine, right? So I require more computation power there. So depending on the workload, what you require more, whether you require more memory, so maybe I'm running in-memory databases, right, that store the data in memory so that you can access at the faster pace. You can use more memory power, and in case if you want to run the batch jobs, the processing task, maybe I'm running the ML task, right, to train my model, right? So I require a GPU support at that point, or require more CPU support at that time to train that. So at that time I require more CPU power. So that's a difference. What's the computation power you require, and what's the in-memory space that you require there for your work. Different workloads has different requirements, and based on that you can select the instance type. Okay?
Understood. Thank you.
Okay, sure. I can see what is a machine, and could you please explain what? Machine is simply I can take analogy, it's my laptop that I'm utilizing right now, right? And what is the configuration of my laptop, right? How it is performing, I can see that here. So for this, I'll quickly bring my laptop here. You can see, right? My laptop has i7 and it's 16 GB RAM. So you can see that how much it is getting consumed. Now, along with this training job, if I want to run some processing behind the scene, but here to train my model, I require more computation power. So what is machine? It's basically a system where you can run your workloads. It's your laptop, if I talk about as an analogy, physical hardware that you are utilizing right now. Your mobile phone is also a machine, has RAM as well and the CPU as well. Same with the virtual machines. What kind of virtual machine you require in the cloud? You can select that for your workload. Okay, T. Awesome. So let's quickly see that mapping. So if I require high performance databases, right? So databases store its state in the memory to give you a faster response. So which kind of instance type can help us out in that case? Which is ideal for databases? What do you feel? Databases want to store its state in the memory. So which option can help you out? I want more memory there, right? So it's memory optimized instances, right? Apart from that, I want a system for running the data warehouse application. So what data warehouse does? It stores a huge amount of data on secondary storage on your hard disk. So which machine can help us out in that case?
Storage optimization.
Right. So there, storage optimize can help me out. You require balanced amount of compute and memory and networking
General
resources.
purpose.
Right. You require high performance processors, more computing power. Right. That is compute optimized, right? So depending on the workload, you select your instance type for your workload, right? And which machines can help you out? Definitely you can use the get advice feature, right? That can help you out where you don't need to get into the documentation part. You can simply get that advice right from the AWS for the same. Okay, now we have seen the options there. Now let's talk about pricing, right? Let's talk about pricing quickly. So of course we say the cloud is pay as you go model. We can access the services on the fly and we can pay the price. But of course, I can also optimize on the cost, right? So one option that we have, which is on demand, which is a default option available to the customers where we don't need to make any commitment, right? So it's on demand. You make a request for a resource and you'll get that resource, right? But this is the costliest option, right? This is the costliest option. Now, if you want to save a cost, now you know that you will be running a database in a cloud for a period of 1 year or for a period of 3 years. You know that you will be running your database for a longer period of time. Make a commitment, right? Make a commitment to the cloud that I will be utilizing the database in a cloud for the period of 1 year or for a period of 3 years. Make a commitment, and this will provide you a discount of up to 72%, right? It will provide you discount of up to 72% over on-demand price. So if you commit to the cloud provider that I will be utilizing the resources for the period of a year or a 3, then it can provide you a discount of up to 72% over the on-demand prices. So if you have a workload that will be running for a longer period of time, go with the reserved instances. That can help you out in saving the cost. Of course, you have on demand, but this is the costliest option that we have. Apart from that, one more option that can provide you a discount of up to 90%, right? Discount of up to 90% over on demand price. Right? Discount of up to 90% over on-demand price, and that is spot instances. right? That is spot instances. Now AWS has already created the infrastructure, right? And the infrastructure, if it is not used, it will not bring any money to the AWS. So what AWS does, it provide the additional workload that is not being used at a discount of up to 90%, right? And how it provide that? With the help of bid. So you do the bid for a resource that for this particular resource, I'm ready to pay this much cost. And if no one is bidding that particular cost, you are the highest bidder, you can get the resource at that cost, right? You can get the resource at the discounted price. So even you can bid for the resources, right? So if I quickly take you to the console, you can see I have a spot request, right? And I'll just click on pricing history, right? So here you can see that the costing, the on-demand price for the machine of type C3.large is $0.1050 per hour, right? But if you bid for this instance, right, at what price you will bid? You want some reference, so you get this pricing history. So this is the on-demand price, and this instance is currently available at this particular price, 0.0319 in one of the AZ. So you can see you get up to 70% of discounts over the on-demand price with spot instances, right? So that's a beauty you have. It might go up to 90% as well. So which is the additional capacity that is not being used by the AWS, right? They provide it as a part of bidding as a spot instances, right? But this instances has a small catch. Today you say that, okay, I'm ready to pay $0.0400, which is the highest price compared to the one that we have here in the screen, right? And tomorrow someone comes, okay, will say that I'm ready to pay $0.500. Then in that case, that person will win the bid and resource will be provisioned to that particular person. So spot instance comes with a catch. If you bid the higher value, you get the resources. If someone comes and bids higher than you, they will get the resources. So that is a small catch we have with spot instances, but of course we can get a discount of up to 90%. So plan how you can save the cost. Don't go with the on-demand instances. It's pay as you go model, but if you have a workload running for a longer period of time, go with reserved instances, go with spot instances, or you can go with the compute saving plan. Again, you can see it can provide you a discount of up to 66% as well, but it requires commitments. So use different plans, either compute saving plan, reserved instances, spot instances to save on cost. Commit your usage, save on cost, or bid the resources, win the bid and use the resources at a lower cost. So plan well as per your application need and save the cost. Okay, is the idea clear? See, for those pricing options, how you can optimize the cost there. Great. Yes, Himanshu?
Yeah, so I have a question regarding this spot one. You said that there is a catch that, if anyone is bidding more than the price that we have bid, so is it like even if we allotted in that slot, still that person can get that spot and then we'll get allocated with that?
Exactly. So you will get a 2-minute notification that within 2 minutes your resources will be taken back. So in that 2 minutes, you can run the automation type task to take a backup so that you are not losing anything. It's not like that someone bidded higher and it is gone. You will get that a 2-minute interval. In that case, you can take a notification. So this is suitable for a workload which is stateless, which is flexible, right? For example, I'm running a machine learning model. So this is my model, right, that I want to train. What I do, I take a small piece of data, I provide this data to the model, I train it. Again, I'll take a small piece of data, I'll provide that to the model, I'll train it. So there, this machine or the spot instances can help me out, because if the machine is taken back, no problem, my model is already trained, I saved my model, my job is done. So this is where it is useful. It's a workload which can start and stop with flexibility. For such workloads, you can use the spot instances. If you don't want that interruptions, go with reserved instances or go with compute sitting plan.
So this is just the test projects, just to test our data and see how the output is. For that, it would be useful. Yeah.
Yeah, exactly. Okay. And how many days instance will be available? There is no guarantee, Durga Prasad. You get the instance, right? It might be available to you for 2 months, 3 months. You decide how long you want to wait for that instance, right? So when I create a spot request, I can specify the interval, how long I want to wait for that resource, right? So I can specify the time limit. Just a second. So I have an option to specify, keep the request valid. I'll not apply default. So here you can see in what period you will wait for that spot instances that you can specify, right? The amount that you have bidded, it will be valid for how long you want to use that spot instance that you can mention here. And within that period, if the price is below your bidding value, you will get the resources. If it is higher, then it will not be granted to you. Okay? Awesome.
And on demand is something we can use if we have 100 headcount, and if we receive for a 200 headcount workload, will it can be switched to the 200 workload?
Yeah, even on demand can do that, because with cloud we have that scalability. No problem in that.
But costing would be different.
Exactly. If you use one machine, it is costing you 0.1030 per hour. If you use 2 machines, multiply by 2. If you use 3 machines, multiply by 3. As simple as that.
Okay.
Right?
And
so the amount of resources used, that much payment.
So Amazon will automatically switch it to the multiple servers rather than we assign it.
No, we need to design such architecture where it can scale, because if you give everything to Amazon, tomorrow it might happen 1,000 servers are there and you will say that why it is there. So somewhere some control is there in your hand as well to make sure that how much you want to scale.
Cool. Got it.
Okay. So you have an option to decide that architecture, how much you want to scale. Okay. And apart from that, 2 more options are available to us. One is dedicated instance and one is dedicated host, right? 2 more options are there. And now this is with respect to compliance. Now what happens in the cloud? Physical server is already created by AWS and you have a hypervisor, right? And on this hypervisor, we can run the virtual machine. So let's say this is a virtual machine which is ran by Kamlesh, customer 1, and this is another virtual machine from customer 2, which is, let's say, is ran by Sora. So it might happen on the same physical server, the virtual machines of different customers are running. Maybe another virtual machine is running, which is from Nilesh, right? So on the same physical server, 3 virtual machines of 3 different customers is running, right? Now your requirement is, whenever your virtual machine is running on any physical server, I have a compliance requirement. There should not be a virtual machine of any other customer running on it, right? So my requirement is only what my virtual machines run on a particular physical server and of no other customer there. So in that case, you can go with dedicated instance. It makes sure that on a physical server, only virtual machines of single customer is running. Only virtual machine of single customer is running. Whether you run 1 machine or whether you run 2 machines, it will guarantee that instance runs a virtual machine for a single customer. So if you have a compliance requirement, you don't want to share your server with other customers, go with dedicated instance. That can help you out, but it comes at a higher cost. So that is also an option to you. If you have a compliance requirement that on the physical server, only your machines, your virtual machines can run and of no other customer. And apart from that, if you need to bind the server-based licenses, right? If you need to bind the server-based licenses, right? You have some server-based licenses that you want to bind to the underlying hardware with the cloud provider, then you can go with a dedicated host. This is the most expensive option in terms of EC2, right? This is the most expensive option you have. So if you want to reserve a server, you want to bind a license, go with a dedicated host. So these are options available to you. Based on your requirement, you can select the same. Okay, is the idea clear? So how you can save the cost and how you can meet the compliance requirements as well if you have any there. Yes, Himanshu.
Yeah, so you mentioned that dedicated instance. So is there any drawback if we share the same with any other server?
There is no drawback. Virtual machines are secured, but if you have that compliance requirements, right? Maybe you are running application, right? Some compliance requirement is there. Because of that, you can go with that particular option. Because by default, in the cloud, we have a shared tenancy. On the same physical server, virtual machines of different customers are running.
Okay.
Okay. Sure. Now let's talk about auto scaling. As we were talking about, I even got the option as well. Probably, I think it was from Nilesh or Himanshu. I can't recall that. If I use 100 EC2 instances on demand, if I want to scale to 200, can we? We can, right? But scaling need to be done by us, right? And there, auto scaling can help me out, right? Auto scaling can help me out, right? So if we take an example of, again, a coffee shop, right now I have 2 customers in a coffee shop. 1 barista is sufficient to serve the 2 customers. As the customer increases, I need to increase the number of baristas as well, so that the customer can get the coffee without much wait there, right? So what we can do, we can increase the number of baristas to serve the customers, right? Moving on, what this EC2 auto scaling is doing, it is doing the same thing for me. It is scaling my EC2 machines based on traffic, right? So on Sunday, I have less traffic. So 1 EC2 machine is sufficient for me to handle the workload. On Monday, I have a little bit more traffic. So I require 2 EC2 machines. On Tuesday, I have more traffic. I require 3 EC2 machines. On Wednesday, I have the highest traffic. I require 4 EC2 machines to serve the customers. And gradually the traffic decreases. Thursday, 3 EC2 machines. Friday, 2, and Saturday, 1. So you can see entire week I have different requirement of a EC2 machine, right? And I don't need to go and sit there every day. I need to change it. With the help of auto scaling, I can configure the threshold, right? I can configure the threshold for the utilization of a machine, and based on that, the scaling will automatically happen, right? So this EC2 auto scaling will make sure it scale my resources based on demand. So this EC2 auto scaling, what I do, I configure what is the minimum number of machines that should be running every day, and what is the maximum number of machine that can run over a period of a time. So I specify minimum number of machines, I specify maximum number of machines that can be running for me with an auto scaling. And how many machine will run, it depends on how many clients you have who is accessing your services. So if you have 2 clients, 1 machine is sufficient. If you have 4 clients, 2 machines are sufficient. If you have 6 clients, 3 machines will be sufficient. If you have 8 clients, 4 machines will be sufficient, right? So based on the traffic that your machine receives, you can decide how many EC2 machines you need to have to serve your customers, right? The scaling happens automatically, but it will scale up to a number, the maximum number that you set here, right? So this is what this auto scaling does for you. Automatically increase the EC2 machines, automatically decrease the EC2 machine based on, rather than customers, I'll say the clients who is accessing your application. Now, how you identify that? How many clients are there? What is the load on the CPU? So for your machines, metrics is available. right? For your machine, the metrics is available. What is metrics? I'll quickly bring here, which is right now you can see the utilization of my CPU, which is close to 80%, right? So if I open more applications, more CPU load will be there, and there is more clients who are sending a request, more CPU load will be there on my machine, right? So I can decide that how many requests is coming to my machine based on the CPU utilization, based on the memory utilization, based on the network traffic. So whichever metrics that you want to utilize to measure the traffic, you can use that metrics. So if let's say I have currently one machine which is running, right now one machine is serving a client, and what happens, my CPU utilization is more than 70%, right? My CPU utilization is more than 70%. So I will scale out the resources. So rather than one, I'm running two machines. So what will happen once two machine comes into serving the customers, this CPU load will decrease maybe up to 38% now across two machines. Again, after some time more customers come, the CPU load across the two machines reaches, let's say 65%, right? Then again I'll add one more machine. So I'll check the metrics of my machine. What is the load on the CPU or what is the load on the memory, and based on that I will decide whether to add the machine or whether to remove the machine, right? So based on that we can decide when to scale up. So with auto scaling group we have a scaling policy, and in this scaling policy I'll simply write a rule. If CPU is more than 70%, add one machine, and if CPU is less than 30%, remove one machine. So I'll configure this particular scaling rule, and based on the utilization of CPU, aggregate utilization, it decides whether to add the machine or whether to remove the machine. So it can scale your resources based on the metrics of your machine, based on the utilizations of your machine. So we can scale out or we can scale in, which is reduce the number of machines based on the traffic that you have on your machines. Is the idea clear? See what auto scaling does for us. Add machines, remove machines based on the traffic. Yes, Kumar.
Then while doing this auto scaling and scaling in or scaling out, how this data redundancy is getting managed here?
How?
How that data redundancy will get managed. Suppose I'm running one application over machine 1. Today I need only one machine, but maybe in tomorrow morning I need two machines, and my customers are coming, and maybe the same customers may come frequency in time and run multiple times. Maybe in one time one machine get catched by that customer, another time machine 2 will get by that customer. So how this the data will be that integrity will be happen? How whatever I have.
Exactly. So one thing we can do is we can store a data at a central store. I have a database. Now both the machines can access the data from the database. Not a problem in that case, if you want to maintain that particular data. And in case if you want to make sure the customer should be able to access the data which is locally on the machine, in that case you can enable the feature of stickiness that also you get. So every time the same customer will be sent to the same machine. So you have this option how you want to handle, whether you want to maintain stickiness where customer will jump to the same machine every time, or you store that in the central data store such as your RDS or maybe S3 as a storage service that you can use there.
Okay. So suppose we use this stickiness, and then each time this machine should know, right, which customer is coming. So same customer you have to identify, right?
So
Then
that
only you can go.
stickiness, we don't have to worry about that. That stickiness will share the token, right?
Yeah.
In the request, and with the help of that they will be able to jump to that particular machine. So that is automatically managed for you.
Okay. Then for suppose number of customers have been stick to the machine one, then this token will generate for each customer. Then how the latency will be here? The performance may be increased for one machine and maybe less for another machine.
So I'll come on that. Just give me 2 minutes because I just talk about auto scaling. Here the customers have freedom to select machine to which they want to talk to. But actually it's not the direct communication between the customer and the machine. It's a load balancer that comes in between, right? So it's a load balancer that comes in between, and this load balancer distributes the traffic across the machine. So customer talks to the load balancer, and load balancer, based on which machine has a less load, it will send the request to that respective machine, right? So I'll talk about that in a few minutes, Pete.
Okay.
Okay. So we talked about auto scaling. Okay, I think Yusuf, any query?
Sorry, Kamlesh. Actually, so database will be for every machine, you said, right? Am I correct?
Exactly.
So in the load balancing NLP, I think data should be on the every machine. Like suppose if there is one common database and we are getting slowly data, means database responding slowly, then what is use of many machines?
So with database, we also have a RDS proxy that can help us out. So what happens with database? You manage a RDS connection, right? So if every machine will keep a connection open, database will not be able to handle it. So what we do in that case, we make a use of RDS proxy, right? So all these fundamentals comes in the associate level courses, right? So rather than talking directly to the database, what we do, we talk to a RDS proxy, right? And this RDS proxy will make sure that to the database only that many connections are opened as much possible. And if there is more than that, this proxy will manage that for you, right? So it, again, if we go dive deep right now in the services, right? Of course we can discuss it, but that's a part of the associate level courses there. In exam, you don't have that depth. You have only questions on the familiarity of the services, what feature that services provides, what that service does for you. This is where you will get the questions there.
Okay.
Okay, Yusuf?
Okay, fine.
Great.
Thank you.
I can see Akshaya. Any query?
Yeah, I have a query. Like we are using minimum instances and maximum instances, right? For the traffic. Yeah. Like how we will pay for this instance?
So the number of instances you utilize, based on that you get the bill, because AWS tells you that. So let's say you are running this machine for 2 hours, this machine for 1 hour, this machine for 30 minutes, right? So in all, how much time you utilize, because this is same kind of machines you have. So 2 plus 1, 3, 3. So it's 3 or 30 minutes for which you pay.
Okay, so we can have maximum number of instances, and only for what we use we are going to pay for that.
Exactly.
Okay, thank you.
Okay.
Yeah.
Great. So it's 8:23, right? We had the discussion on that auto scaling, which scaled out the time. So let's have a short break, right? Once we come back from this particular short break, we'll carry out a discussion with load balancer. Okay, so I'll quickly go back to the timer. And let's have a break. Once we come back from a break, we'll carry out a discussion again.